Hi, I'm Philip Schuchardt. This is a talk on weather for farming. Um, so to just give you a little bit about myself, background. So I started organic farming with my dad about 2 years ago. We operate a organic farm in Elgin, Nebraska. We grow corn, soybeans, alfalfa, and oats. I also do snow kiting in British Columbia, in Squamish, British Columbia, and that's where we tour up into the mountains and try to find wind. And you have to align a bunch of weather together: wind, visibility, avalanche conditions, snow quality. All these things all have to come together to make snow kiting work. And it's similar to farming in the sense that you need to have a bunch of weather conditions that come together to make farming operations happen, and pick good weather windows to do tillage or to plant. And we do a lot of alfalfa haying, so figuring out those weather windows for haying. So giving us a little bit of history on kind of like what weather forecasting can do for you and what it has done for us in the last couple of years. In 2024, we had about 4 cuttings of alfalfa. And only one of those cuttings got rained on, which is great. And that cutting got rained on when I was like, "Hey, Dad, I think it's gonna rain," and he's like, "Oh, we should cut it anyways," more or less. we always talk about it, right? Like funding for this video was and of course it got rained on. It's sometimes you get lucky, sometimes you get unlucky, but using weather models can certainly help with making you more lucky than unlucky. So also in 2025 had a really good success on weather, even though it was extremely wet, really hard to get hay up. We had 2 38-acre fields of alfalfa. We got 4 cuttings each on them. We could have gotten a 5th cutting on one of the fields, but decided not to. Only one of those cuttings got rained on. We nearly could avoid it. A couple different circumstances. I was leaving and we may have been able to get it in round bales. And we essentially had like 6-day weather window, but the sun didn't really come out. Like, it didn't rain on it, but then it just didn't dry down, and then it got rained on. But on the other end of the scale, we had 2 really good high quality cuttings that we were able to get into a building and sell for pretty high dollar hay, which is a really good success on a super wet year. All right, so just to start off too, I like to think of this as all models are wrong, some are useful. And so just to like clarify what I mean by this, you have your random model. So like, for example, if I said on July 7th, it's going to rain 1/2 inch in Elgin, Nebraska, that is a random model. I am basically pulling that number out of the hat, and it's not very useful because it's wrong most of the time. Sometimes you're going to get lucky and it's going to rain 1/2 inch on July 7th, right? But that's a random model. And one of those things would be like the Farmer's Almanac is a random model. It's not that useful. Going more on the scale, more useful models are wrong some of the time, and that's kind of like where your weather models are. But it ranges. It's kind of like a big gradient. And then like really useful models are nearly perfect. And an example of that is like tidal models. So tidal models forecast the tide of the ocean for a particular location. And so you can pretty much go anywhere. They'll have a tidal model and you can see those like a year in advance, and they're going to be really, really accurate. And that's because the sun and the moon don't really change that much. the ocean doesn't change that much, and the land doesn't change that much. So it's easy to forecast versus a weather model. There's a lot of different phenomena that are coming together, and it adds variance to the whole model, and it's harder to forecast for long periods of time. So kind of how I think of it is, you have models that are, the whole idea behind it, any model is to help you to predict the future. You have certainty. It's more certain when you're really close to like in time. So like the day of, a lot of times weather models will be really certain, and then far in advance, like in 2 weeks or in 10 days, the uncertainty usually increases. And I kind of like to think of it as like if I was staring off of a view, if it's the day of, you can see really far in the view, but as you get further in that time scale, it gets more foggy, it's hard to see, and then like way far in advance, you're basically white out and you can't, it's hard to know where you're going. So that's kind of how I think of it. Is I always look at like models of like, what's the certainty of this thing happening and what's the uncertainty, what things are likely I'm not sure about, and what things are like, oh, this is probably going to happen. I also tend not to think in absolutes, like this is never going to happen, this is always going to happen, or this always happens. It's always kind of, I leave room for me to be wrong, because sometimes you get unlucky, sometimes you do get lucky. So weather models in general, they are essentially a big grid over the whole planet. And some models, some are more local. So you kind of have a big grid space that are forecasting across this whole entire grid. They forecast also in an elevational standpoint. So you have the weather models will actually forecast the weather at 30,000 feet. It's not super useful for farmers because we care about what's happening on the ground, even though you need to have those forecasts because what's happening at 30,000 feet affects what's happening on the ground level. And then, of course, weather models forecast during time. So it's kind of like a 4D model. So you have lat long, elevation, and time. And then weather models come in different variety of resolutions. So, for example, you have like a 10-day global model that's going to be over the whole entire globe. It's going to forecast the weather over the whole planet for 10 days. And the grid size on this is quite large. Usually about 20 kilometers, so 15 miles is usually the grid size on that. And then you have mid-range models. They're going to be more regionally based, like on the whole US or all of Canada, or in Europe. You'll have like a three-day model. The certainty in these is much better than a global model. Because the grid size is it's a lot smaller. It's higher resolution. You're going to have more fidelity with a mid-range model. And then finally, you get the highest resolution with a 2D, like a 2-day or less. So this is a short-range model. These are a lot better for forecasting thunderstorms. Thunderstorms are really hard to forecast in general because they're pretty random when they pop up. There's factors that make them forecastable, but it's harder to know exactly like how much rain is going to come into a particular thunderstorm cell, and they're very isolated sometimes. So this kind of gives you an idea of like, okay, for the global models, I want to look at like a long range, kind of get a feel on what's going to go. So in the context of putting up hay, I'll start off with the global model and start looking for those weather windows, those 3-day weather windows. Is it going to be sunny? Is there going to be wind? Is it going to have low relative humidity? And then when that weather window kind of comes closer, I'll start looking at the 3.5-day model to try to get an idea of like, how likely is this going to actually happen, or is the models going to change? These models run, some models run every hour, kind of in the short term. The HRRR in the short term resolution runs every hour. In the mid range, they may run 4 times a day. These models will update And then the global's usually twice a day, once at basically midnight and noon, but that's on like Greenwich time. Anyways, they run multiple times a day. So these models are always changing, and they are essentially initialized with new model data, like whatever is happening at the current moment. And that's why like it kind of changes over time. So it's a good idea just to keep refreshing these models and trying to like see what are they doing to try to nail down, like, is this going to happen or is it not going to happen? Also, your models are going to be like localized to either like the US, or there's Canadian models, there's also European models. These are kind of tuned to the parameters of the geographic area. So, for example, in the Canadian models, they have more parameters for dealing with like Arctic and polar phenomenons, versus in the US models, that doesn't really happen as much. I find that the US model is a little bit better at forecasting thunderstorms than the Canadian models. But, you know, you kind of want to look at weather models that are more specific to your location. Either Canadian and US are usually like the go-to for the mid-range or short-range models. So now let's like actually get into my process for doing weather forecasting, specifically for farming stuff. So if we switch over to SpotWX, I think there's a couple handouts that were given out for that have all these links on here. So one of the things that you should definitely do is in Spot, like what I was talking about, where everything is a grid. So if I click on our farm here in Elgin, Nebraska, it shows up with a bunch of essentially squares on this map. These are actually the grid cells of each individual weather model. And what's nice about this is if you look at like a really short-term weather model like the HRDPS, which is a Canadian model, or the HRR, which is the High Resolution Rapid Refresh, which is a US-based model, you can see that these are really short-range models. This is an 18-hour, and this is a 2-day, so 48-hour model. And you can see how small they are. They cover basically specifically where our farm is located. And what's nice about that is in the summertime when there's big thunderstorms showing up, like the HRR model will actually show you where these thunderstorms are showing up. And if I was taking the weather from Elgin or Neely, you know, there could be a big thunderstorm that rolls over Neely that these forecasts are telling you, hey, it's going to rain in Neely, but really where I am at our farm about 10 miles away, it's not going to rain at all. And so these forecasts will actually show you that fine-grained scale between those two places. So choosing the weather forecast specifically on your farm is super helpful than using the local town that you live near, because it's not the place that you're doing your farming at. So again, I usually start off with the high resolution models, or sorry, the global model. So that's like the GDPS. And let's see if I can probably zoom in on this because it's probably too small for you guys. All right. Oops. Zoom in. All right. So you have all these different weather models. So like I usually click on like the GDPS, for example. And what this will give you is, this is called a meteogram. So the first thing I look at is what the temperature is going to be. So you can see right now it's going to get colder overnight, almost 12 degrees, and then it's going to warm up to almost 60 on Tuesday. And then we're going to have a cooling trend, and then you have relative humidity. So temperature and relative humidity is good. And then these will also show you kind of the storm totals that you are probably going to have. So this is precipitation in inches. So by next Sunday, this model is forecasting 1 inch of snow. And then a great thing to also look at is wind. And that shows you kind of wind direction and speed in miles per hour. The little dots show you gusts. So if I'm trying to cut hay, what I'm looking for is, okay, is there sun? There's no clouds, and then warm temperatures, low relative humidity, and if there's any wind, that's a great benefit. And then you're also just trying to not have precip happen, right? So this is one forecast, and it would be great to see, okay, what's my certainty of that happening? So if we go back, we can look at another global model. This is from, this is the ECMWF. This is a very long range model. It's from Europe. This model actually scores really well from a global standpoint. You can see again, cooling today, and then warming, and then cooling off. And you can notice that our storm total is different in this model than the previous one. So that should tick off in your brain, okay, there's two different models saying two different things. There is snow in the forecast on Friday. I think the other one had Friday, Saturday, and Sunday a little bit. The other one was forecasting up to an inch over that course of the time. This one's forecasting a third of that, only 0.3 inches. What's the deal with that? Well, that's the uncertainty, right? You're oh, there may be snow, but the storm totals are different. And this, as you refresh this and watch it, the snow may disappear or get larger as it gets closer to the actual day. And then we can also look at the GFS. The GFS model is the American model. It's probably one of the older models that are out there. It tends to do a poor job of temperature. It also tends to over forecast precip. I kind of use this one to kind of get a little bit of an idea, but I don't trust it as much as the Canadian and the European model. That's not the case for the short-term models. But again, here it's saying, okay, Friday, Saturday, the storm total on this one is even lower, 0.22. And of course, you have a little bit of chance of snow on that one. And this is for the on the farm here. Now I wanted to go into a little bit. There's this. I picked this one spot particularly for this meeting, just to kind of highlight kind of that certainty type of thing. So right now, it's actually snowing here. And if you look at a 2-day forecast on this guy, you can see, okay, this is the HRDPS Canadian model. It's a really high resolution model. It's forecasting a quarter of an inch. And then if we go to kind of a mid-range, the NAM is also a really great model for kind of mid-range decisions for farming. It's forecasting 0.42 inches today around this time. And then you can look at the RDPS, which is also a mid-range model. It's forecasting almost 0.7, almost 0.8 inches of snow. And you're going, oh, wow, there's a lot of variance, even in this really short period of time, a day away. Here's the HRR, which is updated with radar data. It's forecasting 0.13. So there's a large variance in the snow totals for this particular spot. And you're like, wow, there's a lot of, it's probably going to snow. There's going to be snow falling out of the sky, but we're not quite sure how much is actually going to fall. Why is that? And this is where, looking at a mediagram, you're only looking at one particular location for a forecast. And it's really nice to see everything on a map and see what it's doing. So if we zoom into that one particular spot, and this is at 10 a.m., this is the map. So you can't see all the different kind of weather values at the same time, but you can see kind of a geographic zone of the whole thing. So if we zoom out on this is the HRR model that was forecasting 0.13 basically 1/10 of an inch of snow in that one particular spot in Iowa out here. And that's this little blue area right there, right? And so you're like, okay, the models are picking up on this little signal that it's going to snow here. And you go, okay, that's not very much snow in this model. And you can also see how the HRRR, it's only forecasting in basically the United States. Now, if we choose a global model, for example, say if we use the European global model, this is forecasting all the weather for the whole planet. And it's a really high, like low resolution, large time domain. So you can see here out in where I live in Canada, in the winter, we're getting a lot of rain and snow at the current moment. And so going back to the example here in Nebraska, or sorry, in Iowa, just to show you that little tiny cell that's kind of going through. If we use a mid-range model, we go back to Saturday. You know, this is showing that little cell coming through in that one little spot. And you can be like, oh wow, that's probably why there's a lot of variance, is because it's trying to narrow down on this like one little patch of snow that's falling in this one zone. We can use the Canadian. Again, this is going to show a different result. Like, see how intense this snow is. So this model is forecasting more intensity in that snowfall, but you're still getting the same signal. Oh, there's going to be snow in that zone. It's uncertain how much is actually happening. And you can see how the Canadian model is more driven for Canada, but luckily it covers part of Nebraska. So that's really useful for us. And so you can kind of see like, okay, if I'm looking at my spot forecast and there's uncertainty in the near term, why is that uncertainty happening? What is the kind of the general picture of what the precip is doing in my different area? And that's where Meteor Blue on your sheet, it shows you all these different models. I would stick with the NOAA ones here, the NAM, the GFS, and the Canadian, and then also the European Weather Global is really nice. There's other ones in here as well that you can look at. I like to tie them in with the spot mediagram. And then the question is like, does the actual weather show up with the weather model? So another reason I chose this particular spot is there's actually a traffic cam of this location. If you look at right here, it is actually snowing here, and that is at about an hour ago. We can refresh it and see if it's still snowing. So, you know, the weather forecasts are, those high resolution weather forecasts, it's picking up that little tiny cell, and let's see if it's still snowing. Yeah, it looks like it's still snowing there. I don't know if that doesn't look like an inch of snow to me. So, but it is still snowing. But that's kind of the general trend. That's how I kind of use different weather models to kind of assess what the likelihood of the weather that's going to come to our particular farm in Elgin, Nebraska. Do you guys have any questions?
So, Philip, talk a little bit more about the sheet that you have.
Oh, yeah. So the sheet essentially just has the two links to Spot WX, which is the Mediagram, and then Meteor Blue. If you actually go to Meteor Blue, it will show up with kind of your local forecast, and you'll have to click on the weather maps here, and then that'll get you to the page that I was showing off. And then what's nice about here is you have popular maps. Usually I look at the clouds and precip. That's usually the most useful for farming. We care about when it's going to rain. And then the last link is for my radar. You know, sometimes when you're doing day-to-day operations and you just want to see if a storm's going to hit you or not, looking at the actual radar data is really, really quite useful as well.
So if they hit the QR code on their phone, that brings it up. Is that what you have?
So the QR code is essentially the same thing as the link that's written above there. So you can take that sheet home and type that URL in your web browser, or you can use your phone to get to the same link with the QR code.
What's his preferred model setting the uses the most?
What's your preferred model that you use the most?
Oh yeah, so that's a great question. The correct answer to that is there is no preferred model. I tend to use the NAM is generally one of my go-to mid-range models. I've had really good success with that one. I think the NAM forecasts thunderstorms better in the US than what the RDPS does. Again, the NAM is kind of tuned for North American weather, for US based weather. The Canadian model is more tuned to Canadian weather. There's a little bit different climate there between the two, but the RDPS and the NAM are great mid-range models. I would generally use for long range models, I'd use the European is pretty good and the Canadian's pretty good. The GFS is like meh. It's very mid. It's just old, and it doesn't. You'll just notice that, like, one thing I would recommend that you do is, start playing around with these different models and seeing, like, okay, what did I actually observe versus what did the model forecast on my farm? And really, like, make sure you use the up-to-date one when you're doing that. And like, okay, 3 days ahead of time, it forecasted this much. Now 2 days ahead, it's forecasting this much. Now 1 day ahead, it's forecasting this much. What did it actually happen? And kind of compare the two. And you have to do that for like a decent amount of time to kind of get like an idea of which model is working a little bit better. But again, like a random model will be right sometimes because it just gets lucky. So you have to make sure you remove that bias. But again, the NAM is kind of what I go to for my stuff out in Nebraska.
So you felt you were pretty good this year despite all the rain.
Yeah, I think we did an amazing job despite all the rain for getting hay up. So.
Okay, thank you very much.
Yep.
Let's give them a round of hand.
If you wish to learn more about the weather models mentioned here, visit their websites or download and explore their apps today. Funding for this video was provided by the Transition to Organic Partnership Program and produced by Organic Crop Improvement Association, OCIA Nebraska, chapter members.